Hello students, myself Akshay and you are watching Educare TV. So students, today I am going to discuss about the equilibrium condition. When we say that any mechanical system is in equilibrium condition. So in the last lecture, as we did for the moment, how to calculate, and as well as the force, what the relation between the force and the moment, that we say actually. So today I will continue from that. If a resultant force acting on a particle is zero, that means any particle, more than one forces are acting on that particle, and if the resultant force on that particle is equal to zero, then we can say that the particle is in the state of equilibrium. So this is the case, then the particle will not be having any acceleration. That means when the net resultant force is equal to zero, then either it will remain in the state of rest or it will move in uniform motion, or we can say uniform velocity, because there will not be any type of acceleration on that particle. This condition is called equilibrium condition. So we can one thing also we can write, if the particle is in equilibrium condition, if the particle is in equilibrium, then the particle will be either in rest or move with a constant velocity. So this is the case of equilibrium. So this is for a particle. If we consider a 3D body that which consists of such types of particles are infinite in that body, if we consider that body that is 3D, so what are the conditions for that 3D body? So for that we have to consider all the infinite number of particles that present in that body. So if each and every particle of that body is in the state of equilibrium, then only we can say that the whole body is in equilibrium condition. So is it really possible to calculate or to find the resultant value to be equal to zero for all the particles in a body? No, really it is not, actually it is not possible. So what to do for that? So for that we have an concept, that is for three-dimensional object, the equilibrium condition is vector sum of all the forces that are acting on the body, whole body, that must be equal to zero, as well as the moment about any point, on the body. If these two conditions are satisfied, then only we can say the whole body, that is three-dimensional body, is in equilibrium condition. So what are the conditions? First, the resultant force is equal to zero, and the second one is the moment about any point on the body must be equal to zero. Then only we can say that yes, this body is in equilibrium condition. free body diagram is the rough sketch that we can say, a sketch of an isolated system and external forces that are acting also with the moments that are acting on it is called FBD. So it is basically a rough sketch which includes all the external forces that are acting. So we basically, what we do in this free body diagram, we divide all the components that we have. Say I am starting with an example, then we will understand very easily. Say we have a spring and then a block, say of mass m. So then F force will be acting in the that will be m equal to mg. So what will happen here if we draw the FBD of this system? Then for a spring, this is the diagram for a spring, and for block F force is acting. So if we divide all the two components, then here is also a force that is acting on this block in the upward direction because of the spring. So that will also be in the upward direction, and that will be equal to F. Then only it is in equilibrium, because the net resultant force must be equal to 0. And for spring also, every action there is equal and opposite reaction, as we know from the Newton's law. So this point of contact have equal and opposite reaction. In the block, upward direction, and for the spring it is downward direction. So this will be equal to F for the spring, and in the upper part of the spring, that will also be equal to in the upward direction, and it will be equal to F in magnitude. So this is the free body diagram for this is for a spring and for M. Okay, so this is the basically simple free body diagram. I am taking one more example to clear more about the concept of free body diagram, what we do actually in this diagram. Say we have a can or container in which two balls are there. Two balls are there. Two balls are there. Something like that. This is our can, and we have say two spheres, say A, B. So if we try to draw the free body diagram of this complex system, then we have to first isolate all the components of this system basically. So for A, if you try to draw, this is for A. Here 3 contact forces are acting on this A sphere. First one is the normal reaction due to the container, say F1. This is say contact 1, 2, and this is the contact 3, and this is say 4. Here 4 contacts are there between the all the 2 spheres and the container. So second force that is acting on this sphere is due to this container, and the third one that is acting this force is due to this block B, and it was F2. This was the free body diagram FBD of A, sphere A. For B, if we say for B, if we say this is the force acting on B due to sphere A, and that will be equal to the value F3, because this is the contact forces and they must be equal and opposite, because that was the statement of Newton's third law basically. So it will be equal to F3, and all are vectors. I am not writing every time, but it is quite to understand. You have to understand what they are, vector quantities basically. So one more force is due to the side container, that is in the direction say F4. Here are 2 contacts for this sphere B. Now, and say mass of A, and this is say mass B. So here at the center it will also experience the weight A, okay, and here also it will experience some gravitational force that will be equal to WB, and all are vector. So this is the free body diagram for A and B. If we try to draw the free body diagram for this container, here are 3 contacts, first, second, and third. So first will be, and this is due to this contact surface 2, and that will be equal to F2, because equal and opposite. For this F1 in the downward direction, and it will be in this side, okay, F1, and the third, that is F4, that will be acting in this position, F4. So this the free body diagram FBD of CAN, and this is FBD of sphere B, that was for sphere A. So I hope you have understood about the free body diagram, how to draw basically, and we will talk about the more examples in the next lecture basically. So what is the importance of this FBD? FBD, if we try to analyze any mechanical system about those forces and the laws, if you try to apply, then first step, the first job you have to convert that complex mechanical system into individual all the components with expressing all the forces that are acting on each and every part of that system. Here we have three components. One is can, this is first sphere, this was the second sphere. So what we have done, we have just divide all the components and isolate them. What it means, isolate means you have to consider all the forces that are acting on that body, and as it was in equilibrium condition, so that's why all the forces are equal and opposite. Basically, if we try to find out the F3, that will be acting on both the sphere, that is for A and for B. And okay, so I hope you have enjoyed this class, and in the next lecture we will see about the more complex system. So basically, for this lecture, thanks for watching, at last for watching this video completely. And if you are new to this channel, please subscribe to channel.